Welcome back to the channel, everyone. Today, we're going to talk about chatter. Let's get into it. That sound means something's not right. That's chatter. And if you run a CNC machine, you already know it. Chatter is resonant vibration between the tool and the workpiece. It ruins surface finish. It wrecks tools. It scraps parts. Sometimes the fix can be speeds and feeds. But what about geometry? Today, we have options. Let's take a closer look. Start with a standard 4-flute end mill. Each flute is spaced exactly 90 degrees apart, perfectly symmetrical. That regularity is the problem. When every flute hits the material at the exact same interval, those impacts combine into one repeating frequency. That frequency resonates, it builds, and it becomes chatter. Think of it like pushing a swing. Time your push perfectly every cycle, and the swing goes higher and higher. Same physics, wrong place for it. The first solution is variable pitch. Instead of equal spacing, the flutes are offset from each other. They don't all hit the workpiece at the same time. The stagger breaks the resonance cycle. Instead of one strong frequency amplifying into chatter, you get multiple weaker frequencies that cancel each other out. Same number of flutes, totally different behavior. The second technique works on a different axis entirely. It's called variable helix. The helix angle is how steeply the flute spirals up the shank. On a standard end mill, every flute has the same angle. On a variable helix tool, each flute is different. Each flute engages the material at a slightly different rate along its length. The cutting force is constantly shifting. There's no consistent rhythm for chatter to lock onto. Variable pitch fights chatter at the spacing level. Variable helix fights it at the flute level. Together, they're a strong combination. There's a third geometry feature worth knowing: progressive helix. Instead of changing angle from flute to flute, progressive helix changes the angle along the length of each flute. Higher near the cutting tip, lower toward the shank. The engagement is never constant along the cut. Chatter has nothing to latch onto. Many high-performance end mills combine all three: variable pitch, variable helix, and progressive helix in one tool. The result: less vibration, better finish, longer tool life. Chatter doesn't have to be a machine problem. It's a geometry problem, and it has a geometry solution. At Chapman, we stock high-performance end mills built with exactly these features. If chatter is costing you parts or time, we can help you find the right tool. Just go to shop.wcchapman.com or give us a call at 410-686-6860. WC Chapman, high-performance tooling for shops like yours.